In order to promote and advance science of biology and its application, we are here today to listen to a very interesting speech going to be on corals at risk, the need for protection by Dr. Turney Pradeep Kumar. And I will request Dr. Chinta Pereira to introduce the speaker today.
Okay, thank you, madam. And hello, everyone. Welcome to today's session. And I would like to introduce today's presenter, Dr. Tani Pradeep Kumar. And he was the head of the Department of Oceanography and Marine Geology, University of Tuhuna. Uh, and also he has been actively engaged in marine and coastal ecological knowledge dissemination, management, research assignments and consultancies for more than 20 years. Dr. Turney has taken part in number of environmental assessment studies, contributing as the team leader or marine ecosystem specialist capacity. And he has already published both international and local research abstracts and papers with contribution to more chapters. And currently, he is involved in policy development and on site action, awareness campaigns on coastal and marine pollution control in Sri Lanka. Dr. Turney Pradeep Kumar is currently working as the General Manager, Marine Environment Protection Authority, and served as a senior lecturer to the Department of Oceanography and Marine Geology, University of Ruhuna. So I would cordially invite Dr. Turney Pradeep Kumar to deliver his speech.
Thank you, Chinta. I think you can hear me clearly.
Yes.
So thank you, Chinta, and all the members of IOBs, and we are thankful for you to organize this webinar series on corals at risk, the need for the protection. Actually, this topic is I didn't hear about corals within a couple of months' time in a very active basis, but it's a good time that we started discussing about corals and what is the present situation of corals in Sri Lanka, and at the same time what we have done and where we gone wrong, and what we can do to protect corals in more more broader manner, just to ensure a healthy coral reef system around the country. So it's a kind of academic kind of lecture for within first maybe first 15 minutes. I will tell you what corals are. Then I will move into the importance of corals and threats faced by corals in Sri Lanka. And then I will explain briefly about what are the management measures we have taken so far. And all are from a practical perspective, from my field experiences and other the my work I involved within last couple of years time. So if you have any questions, you can leave at the end, but I'm prepared to answer whatever the questions you are having, but we'll see how it moves. So I'll start. Right, this is my topic, corals at risk, the need for the protection. For the moment, I'm the general manager for MIPA. In MIPA, we mainly focusing on in marine environment protection, at the same time control of marine pollution in Sri Lankan waters. In addition to that, I am a senior lecturer for Department of Oceanography, mainly teaching or doing research, and again engage in oceanography and marine, especially marine related work. So our topic is a coral reef. So here a picture about coral reef, and you can see the coral reef is a kind of barrier that runs along the coastline and parallel to the coast, and that again create calm lagoons just by the coast, and ultimately that provide opportunities for fishing activities, and again tourism, again for the recreational activities. So coral reef are the most diverse of all marine ecosystem in the world, and they team with very high diverse ecosystems, with perhaps 1/4 of all ocean species depend on coral reef for food and shelter during their life cycles. So kind of a cradle for marine diversity, the coral reefs. And they are very much important for the people because they provide alternate livelihood options and food security, and again climate change mitigation factors, and again coastal protection of benefits are there. And the value of coral reef has been estimated at 30 billion US dollars and perhaps as much as say 172 billion US dollar each year is adding and providing food protection of shorelines, job based on tourism and even medicines. And reef cover is just a tiny fraction of the of Earth and is less than 2% of the ocean bottom. And because they are so diverse, coral reefs are often called as the rainforest of the sea. And again, uh, in general, at least 500 million people rely on coral reefs for food, for coastal protection and their livelihoods. And over 275 million people worldwide live in the direct vicinity, very close by coral reefs, and therefore get benefits. And again, about approximately 850 million people live within 100 meters of coral reef. It means they live very closer to coastlines, and because most of people want to become a bit coastal, right? And at the same time, people also pose the greatest threat for coral reefs is a unknown, it's a unseen factor, but is from scientific community, it's a well-known factor. And on the other hand, overfishing and destructive fishing, pollution, warming, global warming, and changing ocean chemistry and invasive species, and all account for the coral reef destruction. As in some places, reef have been entirely destroyed, yeah, and in many cases, places reefs today are in pale shadow of what they once were. And they are kind of three-dimensional living structures comprised of calcium carbonate, tiny uh, polyp shells, and again lots of plants and animals living there. And they are kind of biogenic. The reef is made through some biological process, and you can see a cross section of the coral reef in submerged waters, in shallow water. Uh, Therefore, I can define coral reef as a kind of limestone platforms of shallow tropical areas built by corals or coralline algae. Coralline algae built everything together, and other photosynthetic organisms or symbionts at the same time. Plethora of animal life is there. They live, in kind of collaborating with the reef. And this is a reef at low tide, exposed reef. You can, from here, you can see living coral patches, living coral, those are called coral colonies, and lots of sea algae, sea grasses, and a whole of the, coastal marine diversities can be observed in this sort of very, shallow fringing reefs. You can see most of the places in the country. So let's see what are the type of coral reefs. So therefore, we can easily understand three major types of patch reefs, atolls, or fringing reefs, or bar reefs. These are three major coral reef types: fringing reefs, barrier reefs, and atolls. Fringing reefs are kind of reefs just located by the coast. From the coast, you can easily walk onto the fringing reef. It's a very narrow distance, and from just walking, you can just jump into the coral reef. And because of that, those fringing reefs are very much, hampered by human activities. And if you go along the down south, all the reefs are fringing type. Even in Pigeon Islands and other places, most of the Sri Lankan reefs are fringing type. This again a fringing reef, and this is the most common type of reef. And fringing reef often produce a kind of reef lagoon. This is called reef lagoon. So that provide spaces for especially for tourism and fisheries activities, and again for livelihoods. And these are the kind of the zonation of a fringing reef. You can find reef lagoon and reef flat and reef crest, reef slope, and then reef slope extend into deeper open waters. This is a cross section, right? So here I just want to show, so the distance from the shoreline to the fringing reef is about several tens of meters. Sometimes no coral reefs directly attached to the shoreline. And the lagoon depth is about 5, 6, 7 meters maximum. But when it goes to the bar, this fringing reef, when it goes to bar reef, the distance from the shoreline to the coast, the reef become more extensive, and there's about several kilometers of several nautical miles, 10, 15 nautical miles. And bar reefs located farther away from the coastline. You can't see a bar reef, barrier reef from the coastline. And the depth of the reef lagoon is so deep, about 100 meters or 150 meters. There's a main difference between fringing reef and barrier reef. So, in our planet is a barrier reef. So mainly the distance matters. So here a huge distance from the shoreline to the barrier reef. And barrier reef, the well-known barrier reef is the Great Barrier Reef, GBR, based in Eastern Australia. So you can even see the barrier reef from satellite images, high, very located very far away from the coastline, and therefore very much protected because the very less human activities are happening on most of the barrier reefs. Sri Lanka also have some barrier reefs. I will explain you a bit later. And the third part is the atolls. Atolls are the kind of circular reef. So in atoll, you can see reef crest, reef flat, and reef lagoon. Again, you can find on the other side, reef flat, reef crest, and again open lagoon. So the closest atolls we can see in Maldives, but Sri Lanka, we don't have any atolls located in our waters. So this is a Darwin's theory of the atoll formation. This is a kind of volcano. At the very beginning, fringing reefs are formed around the volcanoes. I hope you can see my cursor, right? And fringing reefs are formed around the volcano, but with the time volcanoes settle like this, right? So ultimately, you will see the only this takes about 500,000 years or maybe million years time. So during this process, the the remaining part is we call it an atoll, and this is how the atolls are formed. So from coral reefs, you can find lots of communities and lower slope, upper reef slope, reef front, reef flat, inner reef flat, various communities depending on the topography and depending on the hydrography of the area, and again depending on the water parameters, water quality features. So depending on the place of the coral reef, the communities differ. So this is the coral distribution in the world. So it's kind of coral is kind of a tropical phenomena. So most of the corals are spreading along the equator in tropics. But if you go to arboreal, or if you go to polar region, you can't find corals mainly because of the temperature factor. But still, you cannot find corals in western coast of South America, again western coast of Africa, mainly because of a process called upwelling. In the upwelling, lots of cold water currents coming up, right? And that brings lots of cold water. Because of the coldness, corals cannot thrive in this area. Therefore, you can't find corals on the western coast of South America and western coast of Africa. And on the other hand, this part is called the coral triangle. I'll tell you why it's called. This is the most diverse coral region in the world. It's called coral triangle. So Coral Triangle is a kind of Indonesia, Malaysia, Philippines, Timor-Leste, Papua New Guinea, Solomon Islands. There's an area where we can find a Coral Triangle, and huge coral diversity, and the abundance is again high. And on the other hand, 95% of reefs are threatened in this area because of the local pressure, and only 3% of MPS or marine protected areas are effectively managed in this coral triangle areas, because in general MPS concept we use, marine protected area concept we use to protect coral reef, but the effectiveness is very less. So this is the coral distribution in Sri Lanka. So in down south from Hikkadu to further down Tangol or Hambantota, Tangolia, you can find coral reefs, but all are almost gone. The living coral diversities, living coral cover is still less than 7% in most of the places. But within last couple of years time, all living corals died mainly because of climate change impacts, again and again because of pollution. And this is in the east coast, Pasikuda, Kalkuda, and Wakare, and again go to Foul Point and in Pigeon Islands, Trincomalee, you can find very good corals. But if you want to see real corals in a very short distance, the best place is to go to Pigeon Islands, right, to see corals. But if you go to west coast, coral starts from off Kalpitia. That reef is called Bar Reef. That's the longest coral extent in the country, but that extends from Kalpitia to mana along the coastline. So Kalpitia, Barif, and again Silavaturi, Aripu, Ankali, those reef range. That's the longest reef range in the country, but still you can find some good reefs in this area. So this reef range, and again the great basses and little basses in of Kirinda are kind of barrier reef type. So that's only barrier reef Sri Lanka is having, great basses, little basses, and again bar reef in Kalpitia, and again reefs in Silavaturi, Aripu, Wankale range. But all the other reefs in the country are kind of fringing reefs, but small. There are small variations called patchy reef and scattered reef patterns. But if I think about the corals in Jaffna region, Jaffna Peninsula, again reefs are in good condition, but the diversity and the distribution is a bit differ from other areas, because in this area the salinity changes very drastically because of the confinedness of the area, and again the turbidity also changes. Therefore, you can find lots of boulder reefs, boulder coral species in this area. Those have a high tolerance to turbidity, especially, and again salinity ranges. But if you go to areas like Trincomalee and East Coast, lots of branching corals are there. In down south, lots of branching corals were there, but for the moment, this has almost gone more than 95 to 96, 95 to 96, 97%. So mainly pollution and anthropogenic impacts. Then these are the reef types and reef distribution. Then we think about what are true corals, what we call as corals, right? So in scientific explanation, corals comes under order Scleractinia, right? Order Scleractinia of phylum Nidari. So they are most of bodied animals, and in the world there are about 2,500 coral species. Most of them are very prominent reef builders, and they always have a calcareous skeleton. So this is a phylum Nidaria. So it has 4 classes, and phylum Nidaria, subclass Hexacoralia, and the orders collected. These are true corals. But if you go to sea animals, carpet animals, and tube animals, and again blue corals and whip corals, those are looks like a coral, but they are not true corals. True corals remain under order Scleractinia, comes under subclass Hexacoralia. All animals comes under Octocoralia are soft corals, but hard corals comes under hexacorals. Therefore, if you, in scientific term, all the animals comes under order Hexacoralia are defined as true corals, right? This is a coral reef in of Trincomalee. This depth is here about 6 meters, and these are very large plates. This is Acropora hyacinthus, and the diameter of this is about 1 meter. So this another coral. This is a small coral colony. Is about diameter is about 6 inches or 10 centimeters. Then I take a closer look to see how this you can see the polyps are, right. So all these small white dots are polyps, and if I can take a more closer look here, you can see these are all of these tiny cups or tiny protrusions are coral polyps, and in the out of the protrusion you can see some tentacles or some fibers, something emerging out. For the closer look in this branch, so this is called coral colony. This colony you can see these are branches of corallums. In the corallum you can find these are called coral polyps, right? So you can see coral polyps. In the coral polyps, it's a kind of small cup-shaped structure. It's kind of yogurt shape, yogurt cup, elongated yogurt cup. So the polyps are living. So when you disturb the coral, the polyps retract into the cup. But when they feed, they come out of the cup and extend tentacles and start, grabbing food from the the surrounding waters. So you can see these are the cups and these are the tentacles coming out, right? And if I take a more closer look here, these are the real coral polyps. They have now totally come out. They have come out from their skeleton. Now they are feeding now, right? They have tentacles, and all the stomach and all the bowels are in this area, right? All the gonads located in this area. So once you disturb them, they quickly retract it into the cup. This one species, these are coral, the polyps of another species. You can see the real mouth here, a slit, and this is hypostoma. This is the area called. Those are tentacles. So by counting tentacles, you can even identify some coral species. It's another species. Still, you can see that number of tentacles and again their mouth, right? So this how these are polyps. The polyps live in a cup. So this cup get together and develop into coral colonies. Coral colonies get together and they ultimately produce a coral reef. And we have three types of coral reefs, right? So if you take cross section here, these are tentacles and this is a mouth. This is the kind of stomach or gastrointestinal cavity. So the gonads are there, the sperms are produced there. At the same time, on their tentacles at the outer layer, there's another tiny algae is living. We call them as zooxanthellae, right? So these algae, they photosynthesis and provide food and produce food and give it to coral polyp. And coral polyp gives some sort of refuge or home for zooxanthellae. So these are kind of a naked eye view from a coral colony. So if you snorkel dive next time, if you look closer closer onto a coral colony, you can even see clearly those coral polyps and retracted tentacles, right? This you can see through your naked eye. Those are a size of sesame seed size of polyps are there, right? Next time when you dive in the reef or when you next time when you snorkel, try to observe coral polyps in coral colonies. And again, this is how this coral polyps are connected to thin, kind of muscle layer, right? So therefore, the coral polyp they communicate for some extent. So if you disturb one coral polyp, others also just retracted through those communication. So if you take a cross section of a branching coral, you see can see it like this. So this is a skeleton. So all the living coral polyps are on the outside, but within the colony, within the polyp, within the coral colony, is kind of dead structure. Only the living coral polyps are living at the outer layer of the colony, right? If you find a large boulder, so only the top layer is living. The layers within that is completely dead, but those are limestone or lime or calcium carbonate secretions. So corals grow about they have very slow growth rate and they take about 50 years to grow up to a football size, and the annual growth rate is about 0.5 to 7 centimeters. In some species they grow about 10 centimeters per year, very rarely. And the nutrition, how they grab food, how they find nutrients, as we just discussed, they catch food using their tentacles. On the other hand, they have zooxanthellae. They produce food and give to the coral polyp. So those zooxanthellae species are called Symbardinium adriaticum. That's one species. But zooxanthellae are the coral species specific. And zooxanthellae produce oxygen, sugar, or food or fat and give the coral polyp. On the other hand, coral polyp provide carbon dioxide and phosphorus and nitrogen to the zooxanthellae, and they live in zooxanthellae live in coral polyp coral tissues, kind of mutualistic relationship. Both benefit, right? These are zooxanthellae. If you take a microscope view, you can extract them easily. In a microscopic view, you can see zooxanthellae like this, right? If you crush a small amount of coral polyps and then you can wash it and filter it, you can extract zooxanthellae very easily. And this is the relationship what corals get and what zooxanthellae receive. And these are the conditions for coral reef to form thrive. They should have a temperature range between 25 to 30, enough sunlight, and at the same time salinity should be around 27 to 40 ppt. uh, uh, they should have a strong, firm base to come and settle. That is why you can't find coral reef in sandy areas, and when there's sandy bottom, you can't find coral reefs are not formed. You can't find coral reef. Therefore, if there's a hard rocky area, coral larvae come and settle and develop into reefs. So they should have a suitable subsurface, and limited amount of the water should be turbulent, lack of sediment, and not too great tidal range, gentle currents, and enough amount of food supply. The area should be a bit fertile, right, or bit productive area. And uh, so since corals is harboring zooxanthellae, and when there's changes in water temperature, corals response, but corals cannot move, but zooxanthellae can move. So therefore, in the case of water temperature changes or any salinity changes, zooxanthellae, they just leave the coral polyp, and then corals convert into very white or very dark, very pale color. The appearance. This process is called coral bleaching. So this is normal situation. Coral polyps. This is a skeleton and coral polyps, and these are zooxanthellae. But this is a bleaching situation. So in the bleaching situation, the zooxanthellae has gone out, and they have now in the water column, they have left the coral, the polyp. But with the time, this case remains maybe couple of 2-3 weeks time. If the zooxanthellae does not come back, these all polyps, they perish, and the whole coral colony die off. Then this muscles also dilute with dissolve in the water column, and new surfaces form in on the new surface. Also microalgae or filamentous algae come and settle, right? So this is healthy coral, this is bleached kind of coral, this is dead coral. So you can see it from here. This is live coral, this is dead and bleached, and this is dead and covered with fungus or filamentous algae or other microalgae, right? But if you come here, so kind of the bleaching is kind of reversible. If the bleached corals are there, if the temperature again come to the normal situation, or the environment become again conducive to corals, they again accommodate zooxanthellae and again revert back to the previous situation. Therefore, bleaching is a kind of temporary stress. It's a kind of phenomena that show by corals, and a kind of stress is a kind of showing up their stress. But if the temperature changes, so if the the stress condition prevail for a long time, they die. Once they are dead, there's no recovery. But bleaching is kind of therefore a temporary phenomenon. In this coral colony, this is living coral, this is recently bleached, and this is dead. So this is the difference between these three phases of their life. So this is the bleaching event happened during the past, and in the first mass bleaching happened in 1985 3-4 period. Then first global event happened in 1998. That also in Sri Lanka also it hit hard. In most of the places, corals died up to 95 to 98%. And in recently, second global and third global events happened 2010 and 2015, and those are becoming very frequent. And this is what happened in 2015 in Polar Reef. This is within a month's time. This is live corals. About 30% of coral cover dropped into 5% within month's time. You can see the difference. This is live corals, but this is dead corals, right? In this period, almost about 98% of corals died in Polhena Reef. This is a kind of temporary bleaching scenario we observed in Pigeon Islands. And then, since corals are very primitive animals, they are having various growth forms, right? These are branching corals, and these are again kind of sturdy digitate type of corals, and these are branching but very short and very tiny, very thin branching, and these are long branching corals. And these are kind of tabular or table corals because it has a one single foot, and from the foot they attach to the substrate. These are called encrusting. They shape the shape of the bottom surface. They grow covering the whole available bottom surface, and they take the shape of the bottom. And these are massive corals, and this is Borealis species, and they become sometimes into several 3-4 meters in diameter. They're huge. Uh, they can be very huge in size. On the top layer, you can find the living coral polyps, right? But if you take cross section, beyond the living layer, all the remaining, the internal areas are dead and but again filled with lime. These are called brain corals because of the appearance they have got the name. These are called mushroom coral. Mushroom corals are the largest coral polyps in coral world. Mushroom, this fungi species, mushroom corals. These are foliaceous kind of montifer, these kind of weed. Once coral recover, these are first species to come and settle. And again, corals are again animals, therefore they reproduce. They have sexual reproduction and asexual reproduction. I will not discuss in deep, but in sexual reproduction, they release eggs. And here you can see they are releasing eggs. And they are another colony, they release sperms. So they meet and develop into zygote, and then zygote convert into a coral larvae. So this is a coral larvae. So coral larvae float with the ocean currents and then find a cleaner, hard substrate. You can see here when the hard substrates are there, and those coral larvae come and settle and develop into a small one single polyp. You can see a dead polyp here, but still you can see the polyp structure here, and divide by budding, and it grow into a coral colony, right? That is the sexual reproduction. But asexual reproduction is by fragmentation, polyp bailouts, asexual planula, partial depth of coral colony, and again budding. There are a number of asexual coral reproduction methods. And because of that, you can use those asexual method to transplant corals. I will discuss this a bit later. And why corals are important? Those are kind of I discuss about the coral biology, basic biology, what corals and how they they are made up of, and what the distribution, everything about coral biology and basic ecology. Now the importance and threats faced by corals. So corals are important in tourism, medicine, coastal protection, and again food and fishing, and marine biodiversity. So I go through this very quickly, right? Ecotourism, and this why tourism, because coral reefs are very colorful, very vivid, and it's kind of unique ecosystem. Once you dove into that, it really you can admire it, to the maximum extent, and you can describe it to people, and it's a unique place. That's why they attract tourists, and it for the country it brings lots of economy, the foreign currencies and help economy. So these are the sceneries, very colorful sceneries you can't see on the land. That's why, and and again some charismatic species like sharks or whale sharks or turtles, and again dolphins, and again various type of groupers, snappers, larger fish, and fish schools. So they really attract tourists, and the same it give a unique experience for you if you dive in a reef. And they are used in as a building material. So this is in Maldives, the coral chunks are used as building blocks, and in Delphi Islands, corals are used in parapet walls, and again this is in Delphi Islands, corals chunks are used to develop a harbor as a breakwater. And it provides food, fish, seaweed, lobsters, mollusks, sea cucumbers, and again coastal protection. So in more than 150,000 kilometers of shoreline in 100 countries and territories receive some protection from coral reefs, right? They absorb the oceanic energy. You can see a reef here. So this reef absorbs all the energy coming through this, ocean waves. So therefore provide calm lagoons. So if you don't have the colonies, the coral reefs, but this is what happened in 1998, Berg et al. He described that Sri Lanka as a country we had to spend about 30 million US dollars in 1994 values to protect our reefs if we did not have reefs. Right now This is about after several years time, you can see how much economic value they provide. And they are highly biodiverse. In coral reefs, you can find all the phylum except amphibians, right? Amphibians, they don't live associated with corals, but all other phylums are there. But if you go to rainforest, you can't find nidarians. You can't find most of the animals living in the reef. You can't find them in rainforest, but in coral reefs, you can find all the biotas available in the planet, right? And it provides 3D structure, give protection for feeding, breeding, and to find their food and take for their security. And again, it provides medicine. Because of that, the coral reefs are called the medicine cabinet of the 21st century, especially in India. Now they are mainly focusing on coral reef organisms for potential chemicals for cancer, arthritis, uh, uh, for bacterial infections, heart diseases, viruses, and other diseases, right? And it provides fisheries opportunities, fish catches, right, and lobsters or crabs or whatever, seaweed, other food source. And again, it's a kind of living laboratory. We can do lots of research on ecology and about evolution and biodiversity, climate change. It's a kind of living lab. Those are the main importance of corals. Then what are the threats faced by corals in whole world? So these are 12 threatened reefs profile in the world, but Sri Lanka is one of them, right? So it's kind of bad news for us. But on the other hand, those threats can be divided into two. First one is anthropogenic threats, and again, second one is natural origin. So 20% of world's coral reefs are under longer term threat of collapse, and again, 33 million areas of coral reefs in 93 countries estimated to be destroyed as a world scale. Therefore, 20% of world's coral reefs have been effectively destroyed and show no immediate prospect of recovery. 25% of the world's coral reefs are under immense risk of collapse through human pressure. 40% of the 16% of the world's reefs that were seriously damaged in 1998 are either recovering well or have recovered. That's a good news, but rest is completely bad news. It means we are losing corals, but scientists predicted by 2050 the coral diversity will almost reach to 5% because of this climate change issues and again pollution issues, right? And again, threats from sedimentation, storms, overfishing, oil spills, physical damage, and sewage pollution. I'll show you. This is dynamites, right? This is kind of in dynamiting within a couple of milliseconds time, they release huge amount of energy. So that destroy everything. This is a coral. This is a dynamite from Mirisa, real dynamite. This is a kind of the gelignite kind of clump and dough. And this is a match, and this is a reef before dynamiting. This is a reef after the same reef after dynamiting. You can see the difference, right? Before and after. So it destroy all the 3D structure and destroy all the marine life there, and again kill all the planktons and fish life, larvae, oval forms, and again all the fish eggs, and within periphery for 1 kilometer diameter. So whole are destroyed within seconds time. And this is a British Sergeant ship in Kayakerni, very highly diverse reef. I got this photograph from Dive Sri Lanka, and this is a very famous place for dynamiting. So this is the result, right? So this is how it was now. This is what is happening there, right? So they kill all the animals, and again they dive and collect, right? It's a very common scene if you go to those areas, but still the law enforcement authorities are working very hard to control it, but still lots of things to be done. This is dynamiting. And fish using fish collection by using moxie-nets. This is again a kind of small mosquito net kind of thing. So they cover coral colonies to extract fish from there. So it's a kind of destructive fishing case, and it's again banned. And dynamite is again banned in Sri Lanka. This is how they use moxie nets. And again, spear guns. In the spear gun methods, you remove all the top predators, all the charismatic species you remove, flagship species, and umbrella species you remove them and completely change the ecosystem balance, right? In spearfish methods. And again, bottom set nets. So this is from Sri Lanka. So they are not meant to be on this place, but fishermen, they lay these nets on reefs. But when they take it out, you can see that see they take this is a bycatch, right, of the bottom set net, and again it destroy all the corals. So these are the results. If you go to Silauturi, Aripu, and especially the west coast, you can see all these these all collections are bycatch from bottom set nets. And again, coral mining is banned, very almost nil now in Sri Lanka, to be honest. But still, coral mining gave a very big blow to corals, maybe in 80s, 70s, and 90s, those period. And collection of coral reef for resources as ornaments. These are again some and again jewelries and an ornamental fish trade. And you can't see this sort of fish in our waters because of this ornamental fish collection, and because our fishermen has so effective, and they have taken everything to zero now, right? You can't see them in shallow waters because of the high pressure of ornamental fishing. And again, these are live fish exports, especially wrestlers, groupers, and they export live as food fish, and this is very common in Sri Lanka now. Again, the tourism. So we think that tourism is kind of helping corals, but there are some instances they really hamper or really cause lots of damages to corals. You can see local tourists. This is in Pigeon Islands, right? They walk on reefs, and these foreigners, they really walk on reefs using fins and cut or break all the living corals there. And these are local fishermen. They walk on reefs, and this is called reef trampling. And they sit on reefs, and you can see their foot. They are resting on living corals. So these living corals are very fragile. So they break in large numbers, and you can see the damage caused within 10 minutes time. How this the feet destroyed corals, and ultimately they end up in coastal waters. After storms and after heavy rain. And yes, these are again from Pigeon Islands. These are kind of propeller cuts, from boats. The propellers, they cut coral reefs, and you can see the damage here. But this is a kind of untouched or undamaged area of the reef, but this is damaged because of propeller cuts, and fishing boats. And again, liquid pollution from failed septic systems and cause development and stormwater runoff and deforestation, oil and chemical spills, and road construction, agriculture. They bring lots of nutrients, toxicants to the coastal waters. You can see, and from oil spill, large oil spill again. You can see what happened in the Covita. And this is kind of this kind of chronic oil spill, small oil spill from FRP or FRP small fiberglass boats. This is kind of because they use two-stroke engines, so this is very common in Sri Lankan waters. And again, sewage and the liquid pollution from coastal cities and coastal dwellers. So because of that, our ocean is dying. These are the dead zone of the ocean. Around Sri Lanka, you can find lots of dead zones. Latest dead zone is in Bay of Bengal. That's about 64,000 square kilometer dead zone was found in northeast of Sri Lanka. So if you collect data from our coastal waters, definitely you will find more dead zones in our coastal waters. And the second pollution is the solid waste pollution. From the coastal solid waste pollution, less than 10% is actually originate from the ocean and coastal areas. About 90% of these pollutants coming from inland areas through rivers and canals. So because of that, in the world, people dump about 8 million metric tons of plastic to the ocean annually. But in Sri Lankan context, these are some examples. This is Negombo. This is Vellavatta. I'll show you some pictures from Sri Lankan waters. And this is Crow Islands. And we, as Sri Lankans, we add about almost 33 million kilograms of solid waste per year to our ocean, right? So when you add plastic or polythene to the ocean, about 70% sink, but only 30% start floating, right? Those 30% coming back to the coast. This represent 30%, right? The remaining 70% is unknown. What's a fate and there's a damage caused by them is unknown. So when they are entered into the waters, they settle on coral reefs, they smother all the bottom living animals, again cause threats to our coastal waters. So rivers, they bring lots of nutrients. So therefore coral reefs converting into algal reefs, and coral reefs are taken by uh, algae, right? So you can see, so because of this is called ecological shift. This is a kind of, diverse ecosystem. Because of eutrophication, global warming and high consumption, they are converting into very barren or algal covered or sometimes fungal covered uh, bottoms without any high diversity, really low diversity is there, right? And this happened, so corals can accommodate these threats for some level, but soon as it crossed the threshold line, it's gone. So it has happened in most of the coastal, ecosystem in the country, especially on the down south and in the western coast, even Colombo waters. This is how they emerge. Algae really emerge through corals, and ultimately, so algae take the advantage and cover all the corals, and ultimately, corals are dead. Corals die by smothering, and again without enough light and sunlight, and again uh, yeah, enough sunlight. And again, other species like tunicates, they spread in very large numbers. This is a Diplosoma virens. Right? One tunicate is spreading in coastal waters, right? And it's a kind of acidian. And if you go to Pigeonarians, you will find another Nidarian. Uh, uh, it's kind of this. They spread in large numbers as as a mat. This again, the damage from tourism is in hit Kadua. So this is untouched or undamaged kind of reef profile. This is damaged, right? Because of the bottom, those plastic, uh, uh, the bottom of this glass bottom boards. This is one profile picture from uh, Valigama Bay as a very very nice picture. But all these boats have their anchors, settled on the reef, right? This is a real picture from Valigama Bay. So again, damage from those boat anchoring. And again, with the time, this climate change, there are a number of, the simulations, number of phenomena, so a number of, so all shows the climate is, ocean is warming and globe is warming. Because of that, we expect very frequent bleaching and a very frequent, stresses for corals. And ocean acidification is very common. Because of that, the ocean coral acidification rate is slowly reducing, and again corals become more fragile, and even coral larvae and coral eggs become more fragile, and that also caused the damage to the initial level of their life cycle, and that they kind of cut all, hamper the whole ecosystem, because once it happened. And again, phenomena like tsunami and others, tsunami, tornadoes. But now even we Sri Lanka observe tornadoes. Earlier we didn't have any records of tornadoes, but now we are experiencing tornadoes. But this is tsunami. This tsunami damage in 2004, they brought they toppled all the corals, and they settled lots of garbage of waste on on corals, and they physically damage coral reefs is in shallow areas. These are some examples from the damage of corals because of tsunami, and again lots of sedimentation after tsunami. And again, the crown of stone starfish. This is a kind of again animal feeding on corals. So this is a coral colony. They come, crown of stone come and cover the colony. So this is how it, once they extract all the polyps. So you can see the damage. So why this happened? Because the crown of thorn has a one predator called triton, or Chironias tritonis. It's a one bigger mollusk, so about 1 feet size of mollusk. So this mollusk is extracted in ornamental fishery for their as a very expensive shell. So once you take this mollusk out, the crown of thorns spread in large numbers and destroy coral. You can see the crown of thorn damage. This damage is patchy, right? So if you see this sort of patchy damage, you can easily understand that there should be a crown of thorn, or there's an infection of crown of thorn in this area. So this is a difference. This is the first photo is a damage of crown of thorn. This is a kind of patchy damage. This is again bleaching. It's a kind of environmental uh, uh, problem, because the reef is bleached in one single in the same manner. So this is how you distinguish the damage from crown of thorn and again environmental parameters. This is what happened in 1998 El Nino. And again, this is a kind of triggerfish. Again, triggerfish are removed for ornamental purposes and again as food fish. So triggerfish are the main predator for sea urchins. So once you take the triggerfish out, urchin starts spreading. So urchin is a grazer. So they graze everything on the bottom, and even they graze coral polyps, very early stage of coral colonies. So they convert the coral reef into barren, calcium carbonate flat platform. At the same time, they burrow into this and they really disintegrate the strength of the reef. So and they spread in large numbers, and this become and convert this coral reef into area never accessible to others because of the damage, right? And the diseases again spread very fast, yellow blotch, and again white band diseases, and again environmental and physiological stresses. Those are diseases. And this kind of reef we call a pinnacle, but looks good. But this coral, the whole coral, the colony is dead. But this what for layman, it's a kind of nice scenery. But this whole colony is dead colony. And because of this, you can see what happened in healthy corals, and again, and 2014 healthy, and 15 February bleached, and 2015 August is now dead. How they convert, the conversion into from healthy to dead corals within almost an year time. This is what happened in Sri Lanka. This is before 2008, before 1998, then before tsunami, and now the situation in most of our reefs. These are kind of reefs. There's no any living corals. Very few corals are there. Kind of we call them as sometimes as coral cemeteries. Very less amount of corals are there, but the majority of them are dead. These are the threats: ocean warming, ocean acidification, cyclones, sea level rise, and these are impacts: coral bleaching, reduce reef calcification, loss of structure and habitat, and reduce water quality. And its consequences: loss of sensitive reef builders, reduced species richness, dominance of macroalgae, lowered coral reef resilience, and loss of, ultimately everything end up in our plates, on our lives, lots of ecosystem goods and services, and end up in and causes of socio-economic issues for the coastal dwellers or for small countries, right? Then how we can manage them? So for the management, what we can do, a number of major steps. We can protect them by banning, we can control them, we can increase the awareness, we can restore and rehabilitate, we can do research, right? Those are the things we can easily do. We can ban them, under Fisheries Act, under Fifth Fauna Ordinance, and again Coast Conservation Act, and again internationally CITES. The transportation of corals and extraction of corals has been already banned, right? And again, usage of dynamiting is banned. Usage of moxie bottom set nets, monofilament net is banned just to protect corals, right? And then just again to protect us, we can declare some MPS, the controlling measures. We can declare some areas as marine protected areas, right? It provide habitat restoration and species restoration, and provide protective places for the animals, right? So these are major benefits of MPAs: protection of habitats, biodiversity, and increased productivity, increased resilience and maintenance of ecosystem services, benchmarking of environmental health, and renewing fish and other marine populations. And we call this as a kind of spillover effect, protection of geological features or processes, protection of cultural values, increased recreation and tourism opportunities, for example, marine ecotourism, protection of economic interest, and encouraging support of marine conservation, and again, education and science. These are the so we can use this declare MPS in Sri Lanka. We have a number of MPS I will discuss a bit later. And in this MPA in Great Barrier Reef, so lots of zonation, right? And you can control some activities. You can control bait netting, boating, aquaculture in lots of in different zones. This is Pigeon Island in Trincomalee. The island is zoning. It has a buffer zone, it has a research zone, it has a snorkeling areas, it has a diving zone. So all the zoning, the legend is here. So in the zoning, in zones, only permitted activities are allowed, others are completely banned in MPS. But this is 40 countries contain no protected reefs in the world, and still some countries they don't have MPS. But even if some countries have MPS, the management goals of most MPS are not met. In this list, Sri Lanka is also there, right? And again, we can declare no fishing zones, and we can declare some closed seasons for tourists and closed season for some fishermen, closed season for some fishing gears. And we can allow some quota system. For example, in Pigeon Islands, we can allow, okay, per day about maximum 500 visitors are allowed. Quota is there. A limited number of boats are there. Those sort of measurements we can take. And again, to awareness, awareness about marine, about the importance of coastal ecosystems, about the environment protection, again, importance of coral reefs, so importance of the biodiversity. You can start from there, at least expecting some long-term, benefits. And again, coral transplantation. This is coral transplantation in Solomon Islands, right? And some examples from there. Then this restore. This is coral transplantation in Polhena using cement blocks, right? And these are some examples, and they start growing. And again, some buried cement blocks in Polhena. Another method again in Polhena with some commercial through some with the support of some banks. So this is how it happened. You can see the block. So they started growing, but unfortunately, these all disappeared after recent bleaching events. Again, you can see the transplanted and very successful projects once, but now it has already gone because of the climate change issues. You can see the block. These are transplanted and well recovered corals. But transplantation is possible, but in that case, you should know the ecology of corals, site selection, species selection, and how to maintenance, and you should be more dedicated for this, and you should have enough time to look after this transplant. So those sort of things matters. But if you do coral transplantation without any of such background, it means you are destroying even the remaining corals, and even the transplant corals you destroy. Therefore, when you do transplanting, you should know the coral ecology, biology, and or the whole coral ecosystem very clearly. And again, these are kind of issues: plastic pollution and fiberglass pollution. And Sri Lanka, we deploy them in shallow water areas, as FADs, fish aggregating devices, expecting more coral settlements, more fish recruitments, and again expecting more fish catch in the area. This happened in Sri Lanka in Trincomalee with the support of Sri Lanka Ports Authority, Sri Lanka Fisheries Harbour Corporation, NARA, Minister of Fisheries, Department of Fisheries, MIPA, and again Sri Lanka Navy and Coast Guard, expecting some more high biodiversity in this area, and lots of awareness and beach cleanup activities and reef cleanup activities to collect a crown of thorn, remove crown of thorn from some reefs. This is from Pigeon Islands. And again, provide alternative livelihoods for fishermen. For example, this fisherman is a reef fisher, and we convert them into a person who do seaweed culture. So those were the possible things, and do some research, right? Number of universities: University of Kelaniya, Wayamba, University of Ruhuna, University of Colombo, University of Peradeniya, Ocean University, and University of Jaffna and Eastern University. They are doing lots of coral research, and lots of agencies like Blue Resources Trust and ORCA. They are doing research on marine biodiversity and marine exploration and marine ecosystem. You can join them and you can work with them. You can explore the present situation of Sri Lanka on regard our marine biodiversity and the latest trends and management issues. And again, more education on marine research, and we can arrange cleanup, so tree planting, step to establish green belts, and you can arrange some commemorative days for World Ocean Day, and again for World Environment Day. The World Ocean is the 8th of June, just to aware people about the importance of ocean, right? Those things you can easily manage. So those are the things happening in Sri Lanka. Lots of things are happening, but unfortunately, corals are mainly depending on us, right? Us means our activities, because corals living in a very shallow, very fragile environment. More we damage that fragile environment, ultimately, the corals, they perish. Therefore, it's our duty to first ensure the ecosystem sustainability. Then from that we can expect that corals will sustain and they will thrive. But without understanding that, if you do more pollution, more unsustainable, if you cannot more unsustainable living, that will ultimately help to kill corals. It means, on the other hand, we being at home, we at our universities or schools, if you become one sustainable means, we are one way or another try to destroy corals in our waters. Thank you for the time. It's almost 1 hour. I discussed a lot, but still I am prepared to answer any questions if you have, and I open the floor for any questions or discussions.
Sir, you mentioned about plastic pollution before. So I have two questions.
Okay.
What is done to stop plastic coming from other countries? And the second question is, do corals consume microplastics?
First thing, yes, the plastic coming from other countries, we call them as transboundary plastics. So we receive, if we take Sri Lanka as an example, we receive plastic from India, Bangladesh, Myanmar, Thailand, Indonesia, China, and again from Australia. We have records for that, but to stop transboundary, so now there's we can't do, because we can't put any fence, or we can't put any boom, because it comes in large extent. So if you develop a boom, it should be large enough to wrap the whole country. It's kind of not practical. Therefore, in global, there are lots of discussions are happening to stop adding plastic to the ocean. So there will be a regional or global mechanism, kind of new convention will come, and countries will be forced to take some measures in the future. But those sort of policy things are happening. But in general, on physically, we cannot stop them coming to our waters. But as a country, what we can do is we can take measures to stop our plastic being added to the ocean. If other countries can do the same, so we can keep the ocean as a place free of plastic, then we can expect that no plastic will come to our waters. But as far as we are not taking those steps, we will receive plastics in continuously until such global measures or any global agreement come into forces. Regarding corals, yes, there are some scientific publications that some coral polyps, they have accumulated microplastics in their tissues. So those publications are now available, and I also have a paper, not mine, but I also received recently a paper that clearly says that coral catch microplastics and settle them in their tissues.
Okay, thank you, sir.
Thanks.
Dr. Tony, yeah, very interesting and very informative speech. Thank you very much. And there are several questions in the chat box. May I put forward to you?
Go ahead, tell me.
Yeah. One is, do we have any marine nature reserves, protected areas in Sri Lanka?
Yeah, we have marine nature reserves in Sri Lanka, starting from Pigeon Islands, Bar Reef, and Pigeon Islands, Bar Reef, Hikkadua, and Buona Vista Reef, those are Sri Lankan MPAs. And let me tell you exactly the
Yeah. Anyway, we have, yes.
we have, but
Yeah.
issue is the management measures, how efficient we are in managing them, right? That's the issue we are facing. And right, we have Sri Lanka we have six marine national parks: Adams Beach, Elf Island, Hikkaru National Park, Usangoda, Chundikulam, and Pigeon Islands. Those are
Yeah.
marine national parks.
Yes.
Marine sanctuaries. We have a list. I can tell you, but those are available.
Yeah, the question is coming from Darshana Dasanayaka. The title is not
Okay.
given, and he has another question. Does Sri Lanka have sufficient statutory provisions to protect marine ecosystems?
Yes, under Fisheries and Aquatic Resources Act, under MIPA Act, under FFPO Flora and Fauna Protection Ordinance, and again Coast Conservation Act. The provisions are there, but the implementation is the issue. We should be more responsible, and we should be more, be efficient in implementing this. But on the other hand, provisions are there, so we have to promote that, and we have to promote from that angle.
Yeah, okay, thank you. Then there's another one small question that is whether the mesopelagic coral reef and the cold water coral, are they both same or different?
Cold water coral,
Migration.
we don't have cold water corals in Sri Lanka, but countries like in Norway, they have a deep cold water corals. In general, we know that corals are very tropical, and they live in very temperatures ranging from 30 to 27, 35 range. But there are some deep water corals in deep fjords in Norway and those areas in North Sea. But in that case, they don't use any sunlight, but they use chemosynthetic measures to produce their food. But that's available. But in deeper areas, you can find some corals. And meso, what's the next question? Meso?
That is a mesopelagic coral.
Mesopelagic means corals.
Maybe the one who raised the question is not clear or something. Anyway, I think you gave the answer to a certain extent. Okay.
Yeah, pelagic is water column. Mesopelagic is a top water column, but corals are they are sessile animals, always living on the bottom. Yeah.
Shallow bottom. Yeah.
Then
there are two questions. I will combine both. The one is the coral transplanted areas. Does Sri Lanka have any exact place for transplanting corals for that type of projects? Are there any ongoing transplant projects?
At present,
also,
we had number of coral transplanting projects happen in Trincomalee and Waligama Kaparatura Reef and Hikkadu Reef, and even Buona Vista Reef. But if you go now, you will see only remnants are there, right? All died and gone.
Yeah. Shall I interrupt you and add one more thing? Under whose authority this transplant project is going on?
Yes, normally corals jurisdiction goes to Department of Wildlife Conservation. So if you do a transplanting project or whatever, you have to take the permission from wildlife, right? But you have to take the consent from CCD and MIPA if you do something in the waters. There's kind of not permit, but kind of consent. But definitely you should take the permission from Department of Wildlife Conservation if you mingle with corals. If you touch corals, definitely it comes under their jurisdiction. Therefore, if you do that without any permit, you will be violating their
okay. Even for MIPA to do such kind of project, you have to get permission from wildlife.
Yeah, what we do is since we are all working in the national level, we collaborate and we do them as a kind of collaborative project.
Okay.
MIPA and wildlife. Then we follow all the procedures, but still we have a better understanding. But we from our side also, we took the whole procedures and everything. We keep the files clear.
Okay. Then there is a question: what exactly the reason for the failure of transplanted corals in Sri Lanka?
Failure of transplant, there's no exact reason, but you should be very, you should know the exact ecology of corals, the biology of corals on the first hand. Site selection, species selection is another one, and ocean water currents and sedimentation level and water parameters, you should know that. And on the top of that, you should be very much, to be prepared to put more effort onto this on daily basis. You have to clean it. You have to be there daily basis. If they are start becoming bleach, you have to remove them and put them in another place. Also, the human skills and labor is needed. So you need that color transplantation need experience and your dedication is needed. Therefore, if you can fulfill all the things, you can do that with the permission. But if you are lacking in one of those aspects, it will become a failure.
Yeah, okay, thank you. Then there is another one. Is there any mechanism, monitoring mechanism for these people who dump unwanted metals and large waste materials into the ocean? Any
Yeah,
mechanism for monitoring?
yeah. For the moment, there is not such a mechanism available, but that's
Hmm?
what promoted to use those CCTV on at least to use some say sonar or radar or remote sensing methods to detect them, because ocean is vast. We don't know where, when they put it, and because in that case the high infrastructure is needed, and in this case those infrastructure is very expensive,
Mm-hmm.
in Sri Lankan context. Therefore, we are now proposing to get satellite images and satellite real-time data, real-time eye on our oceans, and from local level we encourage local governments to establish CCTV or other kind of monitoring mechanisms to in places where they dump in regular basis.
Yeah.
But still those are in very primitive level, but because mainly the issues of implementing this related to financial matters.
Okay, right. Thank you. Then I don't know whether this is under this purview of the presentation of yours. One question to mention about the ICRI program. What is ICRI program? Since Sri Lanka is a member of it.
Yeah, ICRI, that's called ICRI International Coral Reef Initiative. Sri Lanka was a member in ICRI maybe several years ago, and we were very active. And under ICRI, there was a CODIO, Coral Reef Declaration, Indian Ocean, and GCRM and Global Reef, Global Coral Reef Monitoring Network. And in those cases, we were very active, and in that case, IUCN was a focal point in Sri Lanka. But NARA, University of Ruhuna, and other a number of agencies work very closely under ICRI. ICRI kind of now ICRI has become a member under UN, so ICRI has a more kind of power now. So Sri Lanka is a member there, and ICRI has lots of initiatives, but the issue is the funding, right? ICRI is they support technically they support us, and they coordinate in the coordinating level they support us, but in the case of funding they are not so much they don't have enough funding for the moment to
Okay.
as far as I
Then
understand. But we are working with ICRI, and good that we are at least now since once it's died the ICRI program in Sri Lanka, now we is now slowly taking up.
okay, reinitiating. Yeah.
Yeah.
Then you mentioned about several coral diseases. Really, in our case, I think most of us did not know about it. And are there any recorded diseases pertaining to Sri Lankan conditions where the corals been destroyed?
Yeah. Actually, corals it starts with stress factors at the very beginning, then convert into diseases. But I am not so much familiar with diseases. But some people from Ocean University, they are doing research on coral diseases. But if you browse on it, you can find number of issues. The publications on coral diseases, bacterial diseases, virus diseases, and again fungal diseases, and diseases from other environmental stresses. So that's an area definitely. Coral is when think about corals, people are always think about coral transplantation, coral monitoring. But in coral field, there are a number of aspects in Sri Lankan perspective we have not even touched. Right, this is
Mm-hmm.
the areas we can jump in and start exploring. Right, and diseases, coral microbiology, and coral uh, uh, those DNA, those studies are still almost untouched there. So coral disease is another again a place where we can start researching and do lots of things from Sri Lankan point of view.
Yeah, okay. Thank you. Then there is a news article, I think, heard the Great Barrier Coral Reef is almost bleached or dead. Can you please give a brief answer for that? Is it bleaching stage
Now,
too?
as I mentioned, the bleaching is kind of temporary phenomena. So
Yeah.
the whole reef, but in particular places of the reef, recently bleached and some places died, but some places bleached and recovered. Right? Not the whole reef gone. It's wrong, but still, very recently, the whole reef, faced some difficulties because of the bleaching and climate change impacts.
Yes. Yeah. Yeah. Thank you. Then I have a question related to this bleaching stage. Is it
Okay.
the reason for the coral polyps to be died or the Susan Tele
Yeah, in the
getting
bleaching event,
affected? Which one?
even at the in the bleaching event, what happens is the
Huh?
zooxanthellae leave the coral,
Yeah.
then polyp starts starving because of less amount of food. Then polyp
Uh-huh.
can survive at least 2 to 3 weeks. If
Yes.
if the water temperature, or any toxicants, that situation goes back to the normal, the
Mhm.
again can accommodate or zooxanthellae come and settle on corals, and corals again recover. But if
Yeah.
situation prevails for 1 month to 3 4 weeks time, corals die, right?
Yeah.
Because mainly lack of sustainable and lack of nutrition for the food of
Okay.
as food. Yeah,
You mean to say coral polyps doesn't directly affect due to the bad conditions, but it is the Susan Tele.
yeah.
Because of that,
They
indirectly the
yeah
it's
they
getting
they
affected.
also they also feel the stress, coral
Yeah.
polyps, right?
Mhm.
But that's why they kind of regurgitate or expel Susanthale out, because
Mhm.
they are not stronger enough to keep Susanthale in, right?
Mhm.
That situation prevails, they again because of die because of that extending or the this the chronic the stress the chronic level the stress level, they then they die because of lack of substantial and the lack of enough food and then lack of energy.
Yeah. Apart from the larval stages become detrimental for the different ocean conditions. Larvae of
Yeah,
coral larvae. Yeah.
yeah.
Is there a yeah?
Coral larvae, again coral larvae is very much sensitive.
Yeah.
Because coral larvae mainly depending on is a kind of plankton, so coral larvae is mainly depending on ocean currents, right?
Mhm. Yeah.
Climate change, because of the climate change ocean currents changes, they
Mhm.
into offshore and areas where there's no hard substrate or no corals, then again their normal route, the drifting routing is destroyed and hampered.
Yeah.
They end up in areas there's no hard substrate or corals and they normally die off, right?
Yeah.
And again, that's also happen. On the other hand, when the temperature rises, the coral larvae consume their energy to sustain in
Mhm.
this high stress level, and they run out of energy within shorter time, and they perish.
Yes, yes. That gave the answer, I think, for the question raised whether they able to migrate from one place to another, like tropical area to the temperate. I think it is impossible as you gave the answer exactly the perfectly. Yeah.
Yeah, the issue is that coral larvae is kind of plankton. They cannot
Yeah.
swim against any currents.
Yes.
They are therefore they are always depending on ocean currents. So if the
Yeah.
ocean currents changes, they drift with the ocean currents, and they die or settle. But
Hmm. Yeah.
yeah,
Okay. I think you
they
gave.
cannot
Yeah.
they cannot determine their destination by themselves.
Okay.
Yeah.
I think you gave perfect answers for the questions raised by the audience and the participants. And I had to say a big thank you for Dr. Tony Pradeep and
I have
spending
a
his
question.
valuable time.
There's a
Yeah,
I have
you
a
have
question.
any
Good evening, sir.
hi.
and shorter.
Yeah, this is Joshua.
This is from I think from Ghana.
Vietnam, Uganda.
Yeah, Uganda. Yeah, hi Matu.
I'm fine. Like, there is something I wanted to talk about. Like, when you look at global policy when you look at coral reefs in general today, like in the coral triangle, they're like reducing. So don't you think that there is a gap that can be feel like can't, like, you and as an expert, can there be like a global framework developed to manage, for example, the corals? Because I think it's not there, like something like that. Can't we think about something like that? A
Yeah,
global framework.
Yeah, definitely. There's a global agenda comes under ICRI, International Coral Reef Initiative. In that case, support countries like Caribbean Key, the Florida Keys, and again South Asian corals, and we have the South Asian Seas program, and again OSPA program, and those are the small seas programs. So ICRI support them, and always there's a discussion between those the coral researchers, but. For the moment, yes, the ICRI is now becoming so active, and I think in the future there will be a good platform for all of us to meet in very short succession and discuss about the future of corals. And again, each 4 years time, the International Coral Reef Symposium is arranged and again sponsored by ICRI, and GCRM is there. But within last couple of years, it arranged, but in not the scale like how it happened within last 2-3 decades time. But ICRI will take it up, and again from UN level also there is new initiatives. So in Commonwealth also there are some initiatives to take the coral issues to the top. I think in that case. The now there's a good move that the world is now working a bit harder protect corals, because it is said that by 2050 2060 the coral will also the whole the corals will perish and disappear from the system if we keep this momentum, the climate change momentum going.
Okay, thank you.
Thank you,
Okay,
Matava.
thank you. And I will wind up the session today. And thank you very much, Dr. Tani Pradeep. This is the last webinar. We are going to have it in year 2020, and we'll try to do it in the next year as well. And thank you very much for the participants and the audience for attending the interesting and valuable speech from Dr. Tani Pradeep. Thank you very much.
Thank you.